So in this video, I'm going to show you how to start writing circuits in Zebra. So let us see how do we write circuits in Zebra. First, let us open a folder, and we have to open a text document here. I'm naming it test underscore circuit. You can name it anything you want. So in it, everything, all the codes or your circuit descriptions which you write in Zebra have to be written in a text file. Now Zebra has a very elaborate documentation with a variety of codes, a variety of circuits, examples of circuits, and I'm going to use one of those examples. So I'm copying that and pasting it here. So this is my circuit description. So what do these sentences mean? Let us see. The first three sentences, which start with a star or an asterisk, are the comment lines. So everything which is after this star is basically ignored by Zebra and considered to be a comment line. And now let us see, there's another symbol which is very prevalent in this code. So what is that? That's an exclamation. And what does that mean? So this is basically a command symbol. So any word which is after it, Zebra considers that to be a command, but it can't be an obvious, it can't be an random word. It has to be a set of words which is made by the developer of Zebra. And anything which is between these main security, exclamation main security and exclamation in main security, is considered to be the circuit description by Zebra. So let us see the circuit which we are trying to execute here. I have drawn a diagram of that. So it has two AND gates, and basically the output of one AND gate is fed into the input of another AND gate. Now AND underscore 2, this is how we write the basic or fundamental gates. So there are a list of fundamental gates provided by Zebra, and we can get them in the documentation. So these are the fundamental gates. See, and underscore 2 is a fundamental gate which is used here, following the list of fundamental gates which we can used which can be used inside a circuit description without a sub-circuit call. So without an explicit call to a sub-circuit, these are provided by Zebra as fundamental gates. So and underscore 2, or underscore 2, not, NAND underscore 2, NOR underscore 2, XOR underscore 2, XNOR underscore 2, buffer and tri-state buffer, all these are fundamental gates which are provided by Zebra. So what is this convention that is used? And underscore 2014. So these are basically the node numbers. As you can see from the diagram, it has two inputs. So 0 and 1 are two inputs to the and underscore 2, that is the two input AND gate, and 4 is my output node. The second AND gate has 2 and 4 fed into it as the input nodes, and 3 as the output node. Now we come across another command, as it starts with an exclamation, as you can see, that is fix underscore voltage. So what does that mean? It basically tells Zebra that the starting voltage value of node 1 is logic level, of node 0 is logic level 1. Similarly, in the second statement, it tells Zebra that the starting voltage of node 1 is logic level 0. Now we see that my main circuit is ended, and there's something called OT underscore analysis. So what does that mean? It basically tells Zebra that I want the person who is using Zebra, who has written the text file, I want my circuit to be simulated just once. So it's OT analysis stands for one time analysis. So there are four kinds of analysis that you can perform, and OT analysis is one of them. So after that, I have told Zebra that I want to print my nodes. So this is also a command, exclamation print, and I am going to print my nodes 0, 1, 2, and 3. So what is it exactly printing? It exactly prints the logic levels which are present at nodes 0, 1, 2, and 3. So let us save this, and let us see how do I run my simulation. So in the address bar of my directory, I am going to write cmd, and my command prompt appears. And so let us see how we run circuits in Zebra. So anything which we are going to run in Zebra has to be started with this word Zebra. Otherwise, the circuit won't be considered to be a Zebra circuit. So I'm telling Zebra that this is my circuit which I want to execute. So let us see what happens if I press enter. Now there are a set of statements which have come and they are separated. So the first part the first part of the uh, sentences that appear on the command prompt screen, the first section gives the file creation time and the installed Zebra version. As you can see that there's a Zebra version v3.3, and this is the creation time right here. The second section gives the type of analysis that is carried out on the circuit and other general information about the script. So I have performed OT analysis on my circuit, one time analysis. So it is giving me one time OT analysis right here. These are the nodes that to be printed because that's how I've written my code. We can see that and compare. See, I have written print 0, 1, 2, 3. So the nodes should be printed are 0, 1, 2, 3. And the number of nodes, the total number of nodes that are to be analyzed is the total number of nodes in the circuit is 0, 1, 2, 3, and 4. So there are 5 nodes right here. The third section basically provides the information about the pre-simulation. So we have not set up a pre-simulation, so it is showing us no right here. And the next section summarizes the purpose of the analysis type. So we have, see, it's written right here, the simulation calculates the bias point voltage at the nodes, and the node voltages will be printed under the node names. So the node voltages will be printed under the node names. So let us see what happens when I press enter after this. Oh, so the node voltages have been printed right here: 0, 1, 2, and 3, 1, 0, 1, 0. So that is what I have started with. I have started. I have as I've said earlier that fixed voltage basically gives the starting voltage of node 0 as 1. So node 0 has 1 voltage, 1 has 0, 2 has 1, and 3 has 0. So that is the output, basically the output of the circuit, and it also gives the total simulation time. Now I have already installed Matplotlib, PySerial, and NumPy in my systems. They are already installed in my system. So Zebra didn't ask for their installations. But suppose you don't have it, so it will show that it will ask, Zebra will ask you if you want to install them, and you have to press Y for installing them, and then the same thing will occur, that is the simulation will take place and it will give you your output. So that's how circuits are written in Zebra. Uh, so I hope this video helps you. Thank you.